Hi, today we're going to look at extracting metals. So before we look at that, there are 5 retrieval questions. What is meant by the term oxidation? What is meant by the term reduction? Why is potassium more reactive than copper? Why is gold less reactive than magnesium? And how do group 1 metals react in water? So pause the video here and have a go at these, please. Okay, let's have a look. So what is meant by the term oxidation? That's where you're adding oxygen. What is meant by the term reduction? You're removing oxygen. Why is potassium more reactive than copper? Because potassium will lose electrons requiring not much energy. Quite easily lost are the electrons from the outer shell of a potassium atom. Hence, it's far more reactive. Number 4, gold. Why is gold less reactive than magnesium? Again, the same reason. Magnesium, the outer electrons in the magnesium outer shell do not require much energy to be lost, which makes magnesium far more reactive than gold. And how do group 1 metals react with water? Well, group 1 metals react violently with water, lithium, sodium, potassium, and so on, to produce a metal hydroxide and hydrogen gas. I'll move on. So to know how metals are extracted from their ores. Learning outcomes. Explain how metals less reactive than carbon can be extracted from their oxide. This is the main one we're going to take a look at today. You have done this before. So, here's some keywords. I want you to pause the video here and match the keywords to the definition. Okay, let's have a look. So how did you do? Reduction, removal of oxygen. The ore is a rock containing enough metal to make it economical to extract the metal. Reactivity series is a list of elements from the most to the least reactive. Unreactive, this type of metal is found as an element in nature. And the final one, displacement, a reaction where a more reactive metal removes a less reactive metal from its compound. Okay, moving on. Here we go. Most metals are found as ores. So you've got bauxite, which is aluminium oxide. You can see what it looks like. And from that we extract aluminium. You've got hematite, and that's what it looks like. It's iron oxide. And from that we extract iron. Now, you might have heard of hemoglobin. The reason why hemoglobin and hematite, what they have in common is iron. Moving on, malachite, copper carbonate, you can see the colour of it. And from that we extract copper. In ores, the metal or metal compound is concentrated enough to make it economic to extract the metal. Don't forget, companies want to extract it by making it, and they want to make a profit, ultimately making a handsome profit. Some unreactive metals such as gold can be found as metal itself, and so chemical separation is not needed. How are metals found in the ground? Metals are either found pure in the ground, e.g. gold, or as an ore, rock, a compound made of metal and oxygen atoms combined together. So this is a reactivity series, you can see that. So you've got the most reactive metals at the top here. Then semi-reactive, and then these do not react at all, more or less. So they don't need extracting, they're found as the metal themselves, metal as it is, found as native, whereas these metals, zinc, iron, lead and copper, are less reactive than carbon, so they reduce with carbon. Carbon can displace these metals from their ores. Now these metals, the more reactive ones, cannot be extracted using carbon, but instead they're extracted using a technique called electrolysis. And like I said, these at the bottom are found as native metals, uncombined. You may want to copy this down. I'll pause the video here, and when you're ready, we can move on. Okay, let's move on then. How do we extract the metals then? Well, there you go. You've got copper oxide, that's your ore. Carbon is more reactive than metal. So here comes carbon, and there you go. So carbon has displaced. Carbon has displaced the copper to make carbon dioxide. These two atoms are bonded together to make the compound copper oxide. That was before, but now it's carbon dioxide. Okay, moving on. Explain the effects of heating copper oxide with carbon. This type of reaction is where oxygen is removed from a substance. Is known as a reduction reaction. Whenever a reduction reaction happens, an oxidation reaction always happens at the same time. What do you think an oxidation reaction is? Next one, what has been oxidized in this reaction? And why is aluminium not extracted from its oxide by heating it with carbon in the same way? Pause the video, have I got these 4 questions? Okay, moving on then. So how did you do? So if you can explain the extraction techniques, why different extraction techniques are needed, that's grade 5 and above. If you can recall and describe the names of the different extraction techniques, that's grades 3 and 4. And if you can recall the names of some useful metals, that's grades 2 and 3. So I wonder how you did on that one. Okay, moving on. So we need to take a look at how iron is extracted from its ore. There are 3 raw ingredients which we call the charge. Iron ore, hematite, which is hematite, limestone and coke are all dropped in. You can see the blast of hot air. Chemical reaction take place here. Very, very high temperatures. And we get 2 products. We get the molten iron and the molten slag, which is called calcium silicate. If we move on then. Now, here is a slide that you need to know what's happening in the blast furnace and the chemical reaction taking place. So the first one is oxygen in the air reacts with coke to give carbon dioxide, and there's the equation. The limestone then, which is calcium carbonate, breaks down to form calcium oxide and carbon dioxide. The carbon dioxide produced in 1 and 2 react with more coke, which is carbon, to produce carbon monoxide. There, that's carbon monoxide. And it's the carbon monoxide that's the reducing agent, this. The carbon monoxide reduces the iron in the ore to give molten iron. So there's a reducing agent. There's your iron ore, which was a hematite, and you're left with iron. The limestone from reaction 2, this one, reaction 2, reacts with the sand to remove, basically it removes any impurities like sand, and it forms slag, which is calcium silicate. And then both the slag and the iron are drained from the bottom of the furnace. The slag is mainly used to build roads, so they don't throw that away. The iron, whilst molten, is poured into molds and left to solidify. And this is called cast iron, and it used to make railings and storage tanks. The rest of the iron it used to make steel. So that's what happens in a blast furnace, and that's just one way of extracting a metal using carbon. Here are some exam questions. Have a go at these. The iron produced from the iron ore in a blast furnace is called cast iron. Cast iron is converted into steel in a furnace. So question 1. Quarrying iron ore will have an impact on everything near the quarry. Describe one positive impact and one negative impact of quarrying. You can pause the video here. Here we go. So let's see how you did. There's a positive impact and there's a negative impact. You can pause the video here and have a look at these answers. Okay, so after that discussion, let's move on. Draw a ring around the correct answer to complete the sentence. Ores contain enough metal to make extraction of metal 1 mark. Okay, economical. Don't forget, companies are in it to make a profit. Many chemical reactions take place in a blast furnace. Use a flow diagram to help you to answer this question. Suggest how the blast furnace is heated. Suggest how the blast furnace is heated. There you go. Worth 1 mark. A chemical reaction for the extraction of iron is that. Complete the word equation for this chemical reaction. That'll be worth 2 marks. You can see that's the reactant, iron oxide, here. And the other product, apart from iron, the other product is there, worth 2 marks. Draw a ring around the correct answer to complete the sentence. Iron is extracted from its ore by, is it decomposition, is it oxidation, or is it reduction? Reduction, 1 mark. And that's the end of this.